Look at your last few meals. Chicken, beef, pork, maybe some salmon. Now notice what's missing. No wolf, no lion, no fox. In almost every culture, on almost every continent, for almost all of human history, one entire category of animal never makes it onto the plate. Other predators. It's not a coincidence, and it's not really a taboo either. It's math, chemistry, and biology, quietly running the same calculation in every corner of the world without anyone consciously deciding it. To be fair, never isn't quite right. A few predators do end up on human plates. But those exceptions turn out to prove something important, which we'll get to. First, the real question. Why does nearly every human food system independently land on the same answer? Eat the plant eaters? Skip the meat eaters? It starts with a basic rule of ecology. At every step up a food chain, roughly 90% of the energy is lost. Here's what that looks like in real numbers. Producing 1 pound of beef takes around 16 pounds of feed, because a cow only converts a small fraction, roughly 6 to 14%, of the plant energy it eats into actual body mass. The rest goes to moving, breathing, staying warm, just being alive. Now imagine feeding all that beef to a wolf and then eating the wolf. You don't avoid that 90% loss. You add a second one stacked directly on top of the first. A pound of wolf meat would represent an almost absurd amount of grass, several steps removed, funneled through 2 separate animals just to get 1 plate of food. Predator meat isn't just rare on tables. It's staggeringly expensive, biologically, before a single calorie reaches you. Energy isn't the only thing that concentrates as you move up the food chain. So do toxins. It's called biomagnification. When a predator eats dozens of prey animals over its lifetime, it doesn't just absorb their energy. It absorbs whatever pollutants, heavy metals, and industrial chemicals were already inside them, and those substances don't break down easily. They accumulate. This is exactly why health agencies tell pregnant women to limit tuna, but not tilapia. Research tracking mercury through ocean food webs has found that trophic level is one of the strongest predictors of how much mercury an animal carries, and top predators consistently carry the most. This isn't just a lab finding. Arctic communities with traditional diets built around seal and polar bear, both high on their local food chain, have been found carrying measurably elevated levels of long-lived industrial pollutants, a direct human consequence of eating meat from the top of a food web. Then there's a third layer. What predators themselves are carrying. Predators eat raw meat, often from sick or injured prey, and that means they're exposed to whatever parasites and pathogens that prey was carrying, constantly, over an entire lifetime. The textbook example is a parasite called Trichinella, which moves through carnivorous and omnivorous hosts worldwide, and is directly linked to trichinosis in humans who eat undercooked meat from animals like bears. For most of human history, without reliable fire, without food safety inspection, without any way to know an animal's health history, eating a predator wasn't just inefficient. It was a genuine gamble with your life. So, what about bear meat? Alligator? Tuna? The predators humans clearly do eat. The pattern holds up remarkably well once you look closely. Bear meat is eaten in specific cold regions like Alaska, Canada, and Russia, almost always thoroughly cooked, specifically because of that trichinosis risk. Tuna, meanwhile, is one of the most widely eaten predators on the planet, not despite being a predator, but because catching one is comparatively cheap and easy. Fishing changes the entire cost equation in a way hunting a land predator never could. In other words, the exceptions aren't random. They show up exactly where either the danger is carefully managed or the cost of getting the meat drops low enough to be worth it anyway. There's one place where humans are now eating predator meat at a massive growing scale: Fish farms. Salmon are predators in the wild. They eat smaller fish. For decades, farmed salmon were fed exactly that: fish meal and fish oil made from wild-caught fish, which meant the same energy loss problem we just covered, playing out inside an aquaculture pen instead of a forest. But here's what's changed. Over the past 20 years, the salmon farming industry has deliberately re-engineered its own feed to fight this problem directly, cutting the fish meal content of salmon feed from around 65% down to roughly 18%, replacing it with lower trophic ingredients like algae, plant proteins, and insect meal. The goal is explicit: push a farmed predator further down the energy chain, artificially, because doing so makes the whole system more efficient and less wasteful. In other words, we didn't solve the predator meat problem by ignoring the science. We solved it, in this one case, by using the science, deliberately shifting a predator's diet to behave more like an herbivore's, just so the math would finally work in our favor. It's a strange modern twist on a pattern that's existed since prehistory. Humans don't eat predators unless we can find a way to cheat the food chain that made them predators in the first place. None of this required a committee, a rule book, or a shared decision across cultures that never had contact with each other. It emerged the same way independently, over and over, because the underlying math, chemistry, and biology are the same everywhere on Earth. A hunter-gatherer group in one hemisphere and a farming community in another never needed to communicate to arrive at the identical conclusion: herbivores are safer, cheaper, and more abundant than predators every single time. What looks on the surface like a shared cultural habit is really something closer to a law of physics working itself out on a dinner plate. So, the next time you sit down to a meal, there's a quiet piece of ecological math sitting right there on the plate with you. One that's been running in the background of human diets for our entire existence as a species, without a single person needing to understand a word of it. We didn't choose to avoid predator meat because it seemed wrong. We avoided it because over enough generations, the animals that did eat it simply didn't do as well as the ones that didn't. Now that you know why, does it change how you think about the handful of predator meats people actually do eat? Tell me in the comments. If this kind of story pulls you in, the strange, hidden logic sitting quietly behind things you thought you already understood, that's exactly what this channel is built around. Every video here starts the same way: a question most people have never actually stopped to ask, and a deep dive into the real science and history behind the answer. No guesswork, no clickbait facts, just what the actual research says, explained the way it should have been the first time you heard it. If you want more stories like this one, the ones that make you look at something completely ordinary and never see it quite the same way again, hit subscribe and turn on notifications so you don't miss the next one. There's a lot more of this world left to uncover. I'll see you in the next video.